All right, 7.5 properties of trapezoids and kites. This is our last section in this chapter. Again, just like last one, it's got a ton of writing, so I just apologize for that. But then we have a cool picture. At least I think it's a cool picture. Hopefully you think it's a cool picture. Starting off with some definitions. A trapezoid. Trapezoid is a quadrilateral with exactly one pair of parallel sides. Now, some places online, and some books that I've read, they don't say exactly one pair of parallel sides. They use the word with, what do they call it? They say at least one pair. All right. We are using the definition with exactly, right? If you were to use the definition with at least, then we could say a rectangle is a trapezoid, and that's just kind of weird. Okay. So we're saying exactly one pair of parallel sides. So a rectangle is not a trapezoid. Within the realm of trapezoids, we have bases. Bases of trapezoids are the two parallel sides. The legs are the two non-parallel sides. So a trapezoid might look something like this, where this guy and that guy are parallel. This and this, these are the bases. And this, well, let me use a brighter color. This and this, those are the legs. Okay. Now that's just a general trapezoid. The trapezoid that we normally see a lot of the times whenever there's like children's toys with like different shapes on it, whenever you're learning shapes, a lot of the time those are actually isosceles trapezoids. They're a special kind of trapezoid. It's a trapezoid with congruent legs, and these are the ones that I don't know. These are the ones that I always think of whenever I think of the word trapezoid. It's always something that looks something like this. Okay, and then this guy and this guy are equal. Okay. So again, whenever you think about children's toys, a lot of the time they're isosceles trapezoids. So that's the one that we normally think about, but there is the more general term of trapezoids that can look a little bit more funky, like this one there. Let's look at definitions, or actually, what are these? Theorems. 714, the isosceles trapezoid bases angles theorem. How many words can we get there? If a trapezoid is isosceles, then each pair of base angles is congruent. So what does that mean? Let me draw that in on this trapezoid I've got here. The base angles here, those two are congruent, and these two are equal, or congruent. Okay. Conversely, 715, the isosceles trapezoid base angles converse. You can say the thing in reverse. If a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. These are listed separately. We could have listed them together as a biconditional statement, but we've just listed them separately. 716, isosceles trapezoid diagonals theorem. A trapezoid is isosceles if and only if its diagonals are congruent. Okay. Mid-segment of a trapezoid. The segment that connects the midpoints of its legs. Now we need to think about the word midpoint, and then we can think about the word mid-segment. So let me see if I can draw a little picture here. The midpoint of the legs is the middle piece. So this guy and that guy are equal. And then this piece, those are equal. That black line there would be the mid-segment, okay? 717, the trapezoid mid-segment theorem. The mid-segment of a trapezoid is parallel to both bases and its length is 1/2 the sum of the length of its bases, okay? Now that's kind of wordy. What that means is the mid-segment is the average. The average of the bases, all right? That's the way that I think about that, right? You add them up and divide by 2. All right, that's that. Let's look at kite. A kite is a quadrilateral that has two pairs of consecutive congruent angles, okay? That's the difference here, right? A rectangle also has two sets of congruent angles, but a kite is a little bit different. We could probably draw a kite in our head, and you could also recognize that I don't know that kites are parallelograms. Kites are not parallelograms, yes. 718, kite diagonals theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. Right? That's pretty easy to see. 719, the kite opposite angles theorem. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, right? And that should be relatively easy to understand as well. Let's look at this picture. We don't need to draw it, but I like to look at it. We've got all these quadrilaterals at the top. A quadrilateral just means that it has four sides, right? That's all it means. Over here we have parallelograms. And in the family of parallelograms, the ones that we care about at least are rectangles and rhombuses. And then whenever you put a rectangle and a rhombus together, we get a square. Next up we have trapezoid. Remember, the trapezoid can look kind of ugly like this guy here, right? I think that's kind of weird looking. And then we have the special kind of trapezoid, the one that we all know and love, the isosceles trapezoid, where the sides are equal. And then lastly, we have a kite, right? In the kite, let me just draw this in here so that we know the kite's opposite angles that are equal are going to be this guy and this guy, right? We're going to say that this and this are equal, that and that are equal. It's always the one between the two unequal sides that'll be congruent, okay? That's going off of the kite opposite angles, right? Those are the opposite angles that are congruent. All right, let's look at some problems. Number one here. This is supposed to be an, oh my goodness, an isosceles trapezoid. Isosceles trapezoid, right? I didn't write that in there. So we're supposed to list all the other angles of the isosceles trapezoid. We have a theorem here that talks about its base angles. 714, the isosceles trapezoid base angles theorem. So if a trapezoid is isosceles, then each pair of base angles is congruent. So I can say that this guy and that guy are equal. That guy are equal. So I know that measure of angle J is 118. I know that measure of angle L is equal to measure of angle M, and then I don't really know what that is yet. The way that I'm going to get that is I'm going to go back to how many angles, or what's the sum of the angles in a quadrilateral, a four-sided figure. So I'm going to say that I've got, I'll call these x. X plus 118 plus 118 is 360. And so whenever I type that in, I'm going to type in 360 minus 118 minus 118. Oops, that's 188, 118. And then I'm going to divide by 2 because I have two x's. So I have x is 62. And there we are. Number 2, find the length of the mid segment, right? The mid segment is this middle piece here. It's NM or MN, whichever direction we want to say. Now that's going to be the average of the bases. So I'm going to say 18 plus 10 divided by 2. Whenever I add those up, I get 28 over 2, which is 14, right? And this is our answer, 14. Not too crazy. Number 3, find the missing angles. And this is a kite, right? Because it has the double congruent angle, or the congruent sides that are next to each other. This guy and that guy are going to be equal. So I can really quickly say, well, measure of angle F is 110. Now I'm going to go back to the sum of the angles in a four-sided figure, which is 360. So I'm going to say 60 plus, and I'm going to write this as 2 times 110 plus, and I'm going to call GX equals 360. Now whenever I type this into my calculator, I'm going to type in 360 minus 60 minus, I'm just going to multiply that in my head. I got 220. And so X is 80 degrees. Oops, and I shouldn't use a lowercase g there. I should use a capital. So that is that. All right. That's the last of our chapter. Make sure that you have these written down somewhere. Make sure you have all of those. Those will be very useful for you. All right, that is that. Again, I really like this picture. You don't have to copy it down, but I really like the picture. So just wanted to point that out. All right, that's all. Good luck on your homework.